Question number 5, and the line with equation y equals to kx minus k, where k is a positive constant, is a tangent to the curve with the equation y equals to negative half x. Find in either order the value of k and the coordinates of the point where the tangent meets the curve. So it's very simple. So we have two curves and they intersect at tangent. So I will write down here kx minus k, and another one is y is equal to minus 1 over 2x, right? So when we equate both sides, so what we get here, equating these two equations, so we are getting here negative half x is equal to kx minus k over 1, right? When you cross multiply, so this becomes 2k x squared minus 2kx equals to minus 1. So rewriting kx squared minus 2kx plus 1 equals to 0. Now this is a quadratic in x, so we can find out the value of k from here, because for tangent, what do we have? For tangent, our discriminant should be 0 because they intersect only at one point. So discriminant is 0. So discriminant is b squared minus 4ac equals to 0, and b now is negative 2k minus 4a is 2k and c is 1 equals to 0. So this is 4k squared minus 8k is equal to 0. So then 4k is common, we have k minus 2 equals to 0. So from here either k is equal to 0 or k is equal to 2. Now we are given here, if you see they have mentioned here k is a positive constant, so k cannot be 0. So as k is constant, so we are going to reject this value. So we have k is equal to 2, so value of k is 2, right? And the second part we have find the coordinates of the tangent. So for this, first of all I will use this equation number 1. From equation 1 substitute the value of k is 2. So this is 2 into x squared minus 2 k is 2, then x plus 1 equals to 0. So this is 4x squared minus 4x plus 1 equals to 0. Now we can factorize this to find the value of x here. So this is 4x squared, the middle term is going to be negative 2x plus 1 equals to 0, and then 2x is common into, then we will have here 2x again inside, minus 1 and minus 1 is common, 2x minus 1. Okay, so then we have 2x minus 1 equals to 0. So from here we will have x is equal to half, and half it's coming twice, so that means it's the same thing. So now for x equals to half, so the coordinate, that required coordinate we are getting, required point, that is x is half, let's say what is y. So when x is half, then what will be y? When x is half, then y is negative half x, right? So this can be negative 1 over 2 times this is 1 over 2, so this is negative 1, so y is negative 1. So this is our final answer, that is the required coordinate half and negative 1, right? Now number 6, the first 3 terms of an arithmetic progression are given. Given that the common difference is not 0, find the value of p. Now as this is the arithmetic progression, make sure when you read this, this is arithmetic progression now. Now so to find out the common difference, which is d, we can do a2 minus a1 and a3 minus a1. A2, like this the consecutive terms, the difference it going to be same, right? So a2 minus a1, a2 is, we have here 2p minus 6 and a1 is p squared over 6, and A3 is P minus 2P minus 6, right? So now just simplify this. When we take the LCM, this is 12P minus 36 minus P squared over 6. This is going to be P minus 2P plus 6, right? Now we can cross multiply. So this is going to be 12P minus 36 minus P squared equals to, this is negative P times 6. Let me write it down, negative P plus 6, right? So we can add one more term, one more step here. So left hand side is 0, so I'm shifting everything on right hand side. Right hand side we already have here negative 6P and minus plus 36, right? Expanding this bracket, and I'm shifting all these to other side, negative 12P plus 36 plus P squared, right? So from here, rearranging everything, P squared minus, this is going to be 12P and 6, 18P, negative 18P plus 72, 36 plus 36, 72, right? Now again we can factorize P squared minus 12P minus 6P plus 72. Then P, we will have P minus 12 minus 6 common, P minus 12 equals to 0. So P minus 12 and P minus 6. So from here what we get, we have either P is equal to 6 or P is equal to 12. Now let's check when P is 6, what will be the common difference? The common difference, I'm taking the last terms, A3, you can take any of these, but I'm taking the easy one here. A2 was here, we had P minus 2P minus 6, right? So P, if P is 6, then this is going to be 12 minus 6, which is 6 minus 6, it is 0. But we are given that common difference, but it's not 0, so P cannot be 6, right? So that means our value of P is equal to 12, the only value, right? Now next part, using this value find the sum to infinity of geometric progression. Now be careful guys, this is geometric progression, not arithmetic. Sum to infinity for first two terms. So for P, we got P as 12, right? So for P12, what is the first term? A1 is the P squared over 6. That means 12 times 12 over 6, that is 24, right? And A2, the second term, 2P minus 6, 2 times 12 minus 6, this is 24 minus 6, that is 18, right? So now this is first term and second term, and we are looking for now the common ratio. So common ratio R is going to be A2 over A1, that is 18 over 24. Simplify this, this is 3 over 4. Now we are looking for S infinity, sum to infinity. The formula is A over 1 minus R. A is 24, 1 minus 3 over 4, right? So this comes out to be 24 over 4 minus 3, it's 1 over 4, that is 24 times 4, that is 96. 96 is our final answer, right?